In this video, I will show you how to implement overlay analysis using raster layers and how to use task capability in ArcGIS Pro. In this analysis, I want to find those cadastre parcels suitable for building a new public hospital. These are my raster layers. This one is for residential parameter, showing distances from residential land use. This layer is for flood parameter. The purple area is for flood-prone area. And this layer is for existing public hospitals service area. I've done an overlay analysis on these three layers and made this raster layer. The purple area is representing proper areas for building a new public hospital. And finally, the potential cadastre parcels are extracted. Alright, now let's see how we can use task and step by step implement this analysis. For this project, I've created a task from View tab, Catalog pane, Task folder. I'm going to open it. Site selection. Once I select it, a short description is appeared at the bottom of this window. It says this analysis has 3 levels of priority. 1 is for the highest priority, 2 is for the medium priority, and 3 is for the lowest priority. Later, when we are prioritizing raster's classes, we will use these codes. Alright, this task has 2 main steps, data preparation and overlay analysis. In data preparation, we are going to work on analysis parameters, river flood, residential, and drive time. And finally, there is a step for turning vector layers to raster datasets. Alright, let's start from river flood parameter. Preparing this parameter has 4 steps. I've also added a description for each step. Alright, first I need to make sure the latest river flood layer is added into the map. Next, using the tool embedded in this step, I need to make a copy of this layer to make sure the future changes won't modify the original layer. So I'm going to add river flood to the input features parameter. Output location is the default GDB, and I've already defined the output name when I was creating the task. The third bullet point says, from the environment setting, I need to make sure the proper coordinate system is chosen for the output. From output coordinate system, let's choose the maps coordinate system, which is GDA 2020 MGA zone 56 and is the proper projected coordinate system for the study area. Alright, next it says if your chosen coordinate system has a datum different from the input features, we need to choose a geographic transformation. The input layer's coordinate system is WGS 1984. So it has a different datum from GDA 2020, and I need to choose the proper geographic transformation. You can download the list of geographic transformations from Esri website, and I've also added the link into the video description so you can use it if you want. The PDF file looks like this. So we need to find our desired transformation and make sure that this is the right one. Alright, the transformations I need are these 2. It has 2 versions. The second one is for Australia onshore and is okay for my need. And let's run the tool. Alright, I don't need the original layer, so let's get rid of it. Okay, next step says I need to make sure the edit session is on. Then select all features and then merge them. Next, I need to combine the study area and flood layer. And in this example, the study area is Brisbane LGA. So I'm going to add the layer, and using identity tool, which is embedded in this step, I will combine these 2 layers. In the description, it mentions the input features parameter is the study area and the identity features is the flood layer. The output name is already defined, and from environment setting, I'm going to choose my desired coordinate system to make sure the output has this coordinate system. Next step, I need to add new field into the attribute table of River Flood Brisbane layer. Field name and field type are already defined, raster and short integer. Okay, I've got an error because I need to turn off the edit session. Look, the new field is added into the table. Next, I'm going to select features in flood-prone area and fill the cells with digit 3, which is for the lowest priority. And for those not in flood-prone area, I'm going to use digit 1, which is for the highest priority. Alright, river flood is done. Next parameter is residential. The preparation of residential parameter has 3 steps. This parameter will represent distances from residential zones. So those cadastre parcels closer to residential areas have higher priority than others. First, I need to add the latest zoning layer into the map. So let's turn off the edit session and then I'm gonna add zoning into the map. And let's choose a shorter name. Alright, next I need to define a query to only represent residential zones. I can do this from Tool dialog box embedded in this step. First, I'm going to add the layer and then choose LVL1 zone, contains the text, residential. And from environment, I'm going to choose my desired coordinate system. And let's check the input layer's coordinate system, which is GDA 1994 datum. So I need to do a geographic transformation. And let's run the tool. Alright, only residential zones are exported. Next, using Euclidean distance tool, I'm going to calculate distances from residential zones. Let's add residential layer as input, and from environment, let's choose the proper coordinate system. But at this step, it's not necessary to do so, but I'd rather to get used to it. Alright, there are 2 important points here. For snap raster and cell size parameters, it's better to choose a base raster and use that raster for all rasters in this analysis. So I'm going to add my base raster into the map. And now I need to open the tool again to be able to see the raster's name. Okay, now I'm going to choose this base raster for cell size and a snap raster. These 2 parameters are so important for overlay analysis because they help all cells exactly sit on top of each other. Alright, the second point says for mask and extent parameters, I need to choose the study area, which is Brisbane LGA in this case. Look, cell size is changed to the base raster. For distance method, I will leave it as it is. But if we are working on a huge area like a continent, it's better to choose the geodesic method. I will put a link to an article from Esri in video description for those who want to know more about these two methods. Alright, next I need to reclassify this raster to classes suitable for the analysis. If you remember at the beginning of the video, I've mentioned this analysis has 3 levels of priority, and now I want to classify Euclidean distance raster into these 3 classes. Let's add the input raster, and from classify let's choose 4. Details are written in the step description. The first class is from 0 to 0 for those cells that overlap with residential zones. Next is 0 to 1000 meters, and from 1000 to 2000 meters, and 2000 plus. The 0 to 0 class has the lowest priority because they are residential and we don't want them for hospital. 0 to 1000 priority 1, 1000 to 2 priority 2, and 2000 plus again priority 3. So we have 2 classes with priority 3. Let's toggle on change missing values and run the tool. The lowest priority is the blue one, residential zones, and cells further than 2000 meters from residential zones. The pink color has the highest priority and the green one has the medium priority. Alright, residential is done. Next parameter is existing hospitals service area, and I'm going to use network data for that. First, I'm going to organize the TOC. So let's put residentials in a group layer. And also put river floods in a group layer. Alright, at the first step of this parameter, I've embedded a tool which is made in Model Builder and is created using a workflow in network analysis called service area. I will talk about it more when I'm creating the task. The input facilities parameter is existing hospitals in this case. So I'm going to add the layer into the map. And since I only need those hospitals in Brisbane LGA, I'm going to select those and then add the layer into the tool. For the next parameter, I'm going to enter my desired drive time from existing hospitals. Let's add 10 and 15 minutes and run the tool. But notice this tool uses AGOL credits. Alright, now let's add the polygon output to the map. (10 minutes and 15 minutes service area are created. In the next step, using identity tool, I'm gonna combine the service area and Brisbane LGA layer. So input is study area and identity is service area. Output name is already defined, and let's choose the proper coordinate system from the environment setting and run the tool. Look, these purple areas didn't have overlap with Brisbane LGA and are taken out from the identity tool's output. We want all analysis layers cover the same area, which is Brisbane LGA in this case. Next, I need to add a new column into the service area Brisbane layer. Field name and type are already defined, which is raster short integer. I just need to run the tool. Alright, here is the new column. Now I need to enter code 3 for those features in 10 minutes drive time of existing hospitals. If you remember, code 3 was for the lowest priority, so we don't want the new hospital be within 10 minutes drive time of existing hospitals. And let's put code 2 for those in 15 minutes drive time. And for those not in existing hospital service area, let's enter 1, which is the highest priority. Alright, existing hospital service area is done. Next, we are going to turn this layer and the river flood layer into the raster format. Let's organize the TOC first. So I'm gonna put service area layers into a group layer. Alright, for this step, I'm using the batch version of feature to raster. This way, I will be able to run the tool for multiple inputs. Okay, let's add the inputs, service area, and river flood. For field parameter, I'm gonna add the field that its values will be used for output raster's cell values. So I'm gonna choose raster, which I've already defined in these 2 layers. For output raster, I've used inline variable substitution technique. So this way I can have dynamic names for output rasters. Actually, using the name keyword and percentage signs, I can use the inputs names for outputs. Alright, from environment setting, let's choose the proper coordinate system. But actually it's not necessary to do so because the inputs already have the proper coordinate system, but I'd rather to get used to it, so I did it. For extent and mask parameters, let's choose Brisbane LGA. And for cell size and snap raster parameters, let's choose the base raster and run the tool. Alright, my analysis layers are ready. One for river flood, which has 2 classes, one for service area, which has 3 classes, and one for distance from residentials, which has 3 classes as well. These 3 layers have several important characteristics. All these 3 layers are covering the same area, which is the study area or Brisbane LGA. All these 3 layers have the same coordinate system, and all these 3 layers have the same cell size and are snapped to the base raster's cells. So when I want to implement the overlay analysis, all cells of these 3 layers can exactly sit on top of each other. Alright, now that analysis layers are ready, let's do the overlay analysis. The data preparation step is done. Now let's implement the overlay analysis. First, let's shorten these layers' names. Now, using raster calculator tool, I'm going to combine these 3 rasters. Using the plus operator, I can sum up cell values. And by dividing into 3, the output raster's cell values will be between 1 to 3. If I don't do this division, the output cell values will be between 3 to 9. So it's up to you. The output name is also defined, and let's run the tool. Next step, I'm going to reclassify this raster to have 3 integer classes, 1, 2, and 3. So the input raster is the output overlay, and I'm going to define classes from classify button. Let's choose 3. And toggle on change missing values to no data, rename the output, and run the tool. Alright, the final raster is created with 3 classes. The blue one has the highest priority, and the green one has the lowest priority for building the new hospital. If you want the area of each class, you can use both raster and vector layers. Look, in the attribute table of this layer, I can see the number of cells in each class. So I can multiply cell size with the number of cells in each class, and this way calculate the area for each class. But I don't need this information right now, so let's go to the next step, raster to vector. Add the classified raster into the input parameter. The output name is already defined. Let's choose the proper coordinate system and run the tool. Alright, now I'm going to define a query on this layer to only represent those in class 1, highest priority. Next, I'm going to overlay this layer and cluster layer to extract those parcels with the highest priority for building the new hospital. So let's add cluster layer to the map. Alright, now input feature is cluster. Relationship parameter is already chosen, have their center in, and let's choose output overlay vector for selecting features. Alright, those cluster parcels with the highest priority for building the new hospital are extracted. In the next part of the video, we will see how to create this task. For this part, I've created a new project. From Insert tab, Task, I'm going to create a new task. From New Group, let's create a new folder and call it Site Selection. For description part, you can write it in your own way. I've got this description from the task I've used for the first part. Now, using new task option, I'm going to create a new task and call it data preparation, which is the first part of the analysis. And let's create another task and call it overlay analysis. Now, let's go to the data preparation and work on its steps. What I need here is a palette, but it's like first I need to create a blank step and then create a palette. And then I can delete the blank step. Alright, now I'm gonna create a new step in this palette, but first let's rename this step to river flood, which is the first parameter. Alright, what I want to do in this step is adding the latest river flood layer into the map and make a copy of it to make sure the future changes won't modify the original layer. Okay, I'm gonna call this step export. And let's copy the instruction from the task I've already created. Alright, now from actions, set the command. Let's choose the geoprocessing tool and look for feature class to feature class. Sometimes there may be several tools being able to do the same things, so it's totally up to you that which tool you're going to use. Alright, here I can hardcode the output name and done. Okay, after exporting the river flood, I want to merge features in this new river flood layer. So let's call it merge and copy the instruction. And from actions, this time I'm going to choose command and search for merge. In the next step, I'm going to combine the river flood with the study area using Identity tool. So let's add a new step and call it Identity. Again, I'm going to copy and paste the instructions. And for actions, let's choose Identity tool. And here I can hard code the output name. Alright, finally I'm going to add a new field into the Identity tool's output. Let's call it Add field, and from actions, let's choose the Add field tool. I can fill the field name and field type parameters with my desired values, raster and short integer. Alright, let's just toggle on this optional option to add a skip button into the step and simply skip it when we don't need it. Okay, now let's add a new blank step and create a palette for residential parameter. I can either keep this blank step for the next palette or delete it, but I'm gonna get rid of it. Let's call it residential and toggle on optional. The first step is exporting the zoning layer. So let's call it export. And from now on, I'm not gonna copy and paste the instructions. Let's just focus on actions. I'm gonna choose feature class to feature class tool. And let's hard code the output name. All right. Next, I want to calculate the Euclidean distance from residential zones. So I'm going to call it Euclidean distance. And let's choose Euclidean distance tool. And finally, I'm going to use reclassify tool to reclassify the Euclidean distance raster into my desired classes. Let's call it reclassify and choose reclassify tool. Alright, the residential parameter is done. Next parameter is the existing hospital's service area. For this parameter, I've used service area in network analysis. But this workflow is not a tool to use it in my task. I need to create the tool. So I'm gonna open Model Builder and create the tool. First, let's add Make Service Area Analysis Layer tool. Next, let's add Locations tool. And finally, I'm going to add Solve tool into the Model Builder. Now, let's connect the output from Make Service Area into the Add Location. And let's connect the Add Location step into the Solve tool. For the first part, for output geometry, I'm going to choose Dissolve to have only one feature for each derive time, not multiple features. And for collapse parameter, I'm going to add a variable into the model. Its type needs to be double, and let's choose multiple values. And here I'm going to choose cutoffs. And let's get rid of those default values. And here let's choose parameter to make it the tool's parameter. For add location, input locations parameter, again, I'm gonna add a variable into the model, and let's choose feature layer, which is for public hospitals. And let's connect it to add location. And let's rename it to public facilities, for example. And I'm gonna choose parameter to turn it to tools parameter. All right, this way I can create the service area tool. And finally, I'm gonna save the tool in this project's default toolbox. All right, now I'm gonna add a new step and call it service area. First step is creating the service area. So from actions, geoprocessing tool, I'm gonna search the tool I've just created. Look, the toolbox name is written here. And this way I can simply embed the tool in this step. Let's just toggle on optional. Okay. Next step, I'm gonna use the identity tool to combine the service area and the study area. I can hard code the output name and done. And finally, I'm gonna add a new field into the identity tool's output. So let's call it add field and choose add field tool. I can also define the field name and field type. All right, service area parameter is done. Next step, I'm gonna turn the service area and river flood vector layers into raster. I'm gonna add a new step and call it feature to raster. And toggle on optional. For this step, I want to use the batch version of feature to raster tool. So I'm going to search the tool and choose the batch option. The batch parameter is input features. And let's turn on save the batch tool to be able to use it in my task. Let's accept the default name and it goes straight into the default toolbox of this project. So let's leave it as it is. All right, the batch tool is created. It's time to add it into the task. Let's search its name and press OK. I can hard code the field name. And for the output name, I'm going to use inline variable substitution technique. Actually, by using name keyword and percentage signs, I can use input names for the outputs. It's totally up to you what values you are gonna hard code. Alright, data preparation is done. Now let's work on overlay analysis. Let's go to the overlay analysis and add a new step and call it raster calculator. At this step, I want to combine 3 rasters created in previous steps and create a new raster using raster calculator tool. And let's toggle on optional. I can also define the output name. Next, I'm going to reclassify this overlay raster into my desired classes. And let's toggle on optional. So let's find reclassify tool and embed it into this step. Again, I can hardcode the output name. Next, I'm going to turn this raster layer into vector format. So I'm going to use raster to polygon. I can also define the output name. Last step, I'm going to overlay this layer with the cadastre layer and extract those cadastre parcels located in priority 1 area. So let's add a new step and call it select by location and toggle on optional. I can also define the relationship type, for example, have their center in. Alright, overlay analysis is done. So by using this task, I can simply implement a raster overlay analysis.